Hi, all. Welcome back to our YouTube channel. I hope you all are doing fantastic. Topic that we will be having a look today is bond pricing. So we'll look at one of the numerical from bond pricing. And please do subscribe to our channel, like, comment, and share with your peers so that we can reach out to maximum audience and they can get benefit out of it. So let's have a look at the numerical. Give me a moment. Let me switch on my pen. So yeah. So there are the cash price of 6 month and 1 year bond. So the price for 6 month and 1 year treasury bill, sorry. So the difference between treasury bill and bond is, so in the next part, we have been given treasury bond and in the initial part, we have been given treasury bill. So difference is like there is no coupon for treasury bills and 6 month and 1 year, the prices are 97 and 93. And for 1.5 year and 2 year treasury bonds, for them the coupon is 6% per annum. Sell at the prices are given, and we have been asked to calculate 6 months, 12 month, 1.5 year, and 2 year spot rates with a semi-annual compounding. Of course, our treasury, the compounding frequency for treasury is semi-annual. So I have just summarized this, whatever information we have been given. So the tenors that are into consideration are 6 month, 1 year, 1.5 year, and 2 years. And so basically, because we are dealing with treasury bonds and treasury bills, the compounding frequency is 2. So the formula that I'll be using, I'll show it to you in next slide or in this slide. So it's a compounding frequency, and that because it's semi-annual, so there will be 2 compounding happening in a year. And coupon, like in treasury bills, there are no coupons. These are zero coupon. So there are no coupons. So we have, and price for those are for 6 months, it's 97. For 1 year, it's 93. And 1.5 year, it's 98.5 with 6% per annum semi-annual compounding. These are very important and these are quite confusing at instances, like compounding frequencies and like the annual interest rate is per annum, but compounding frequency is semi-annual. So you need to be very careful. I'll explain in detail when I'll be explaining the formula. Similarly, for 2 years, 6% per annum with a semi-annual compounding. The price for this is 98.5 and price for this is 97.5. So let's have a look. And the formula that I'll be using for zero coupon, like it's very intuitive formula. So if I talk about price for zero coupon bond, I'm just writing zero over here. It's like whatever you call it as face value slash par value, whatever your maturity value is, divided by, very important now point to be taken care is R over N, where N stands for compounding frequency, over to the power N into T. So very important. I mean, just remember this formula. You will not get confused ever. So R over N, where N is compounding frequency, to the power N times T. So this is for zero coupon bond. And for coupon bearing bonds, so I'm just writing it over here with the heading coupon bond. So formula for price of this is, so you discount your coupons at a spot rate. So like whatever spot rates are there till like n is like I would say RT rather. So whatever is a corresponding spot rate for that maturity divided by compounding frequency to the power T into N plus because you get your par value back at a maturity. So you can say par value, face value, whatever you call it as, par value divided by 1 plus RT divided by N to the power T into N. So these are very important formulas that we'll be using to solve above problems to calculate spot rates. So in this, if I were to show you what, so prices are given. If you look at this, the prices are given. So left hand side, this is given for both all the four scenarios, and we have to calculate somehow spot rates. So let's look how we do it. For first bond, which is a 6-month bond with 97 price, let's see how we calculate using this formula. So for 1 and 2, I'll be using this formula. For 3 and 4, so if I call this as 1, this as 2, this as 3, and this as 4. So for 3 and 4, I'll be using this formula, and for zero coupon, I'll be using this formula. So for 6 months, zero coupon price is 97. Let's have a look. So as per the formula, the price of 97 is given, and the par value is 100. How we will get it this? It's like 1 plus R we have to calculate. Because it's semi-annual compounding, R is 2, and like into the par, it was T into N. So for this, uh, T is like, if I'll just write first N, it is 2 compounding frequency. And for this T, be very careful. See, given it's a semi-annual 6 months bond, so T is just 0.5 years. Okay, so be very careful. And what we'll do, we'll just, and 2 into 0.5, it would be 1. So I'm just solving this for first case. So I'll take this on left hand side, and I'll bring this 97 in a denominator of right hand side. So what I'll get 1 plus R over 2 to the power 1. So I may not write, and it's 100 over 97. So 1 plus R over 2 to the power, if I calculate 100 over 97, it's like, let me just calculate it. It's coming around 1.0309. So if I take 1 minus on that side and multiply that by 2, so my R would be equal to 1.0309 minus 1 into 2. So let me just calculate it quickly for you. Into 2. So it's like 0.0619, or I can say R is equal to 6.19%. So for 6 months spot rate is 6.19% per annum semi-annual compounding. Very important. So it's annual interest rate, but compounding frequency for this interest rate is semi-annual. So this was 1. Let me calculate number 2. Let's see what was number 2. The number 2 was, price was 93 for treasury bill, and the maturity is 1 year. Let's calculate what's the spot rate. So the price is 93. It's equal to, same formula, R value would be 100, and 1 plus, we have to calculate spot rate, semi-annual compounding to the part 2 into, this time it would be T will be equal to 1. Okay, because it's 1 year. Over here it's 6 months. Okay, so it's 93 is equal to 100. So let me just rearrange these terms instead of writing it again. So it's like 1 plus R over 2. So I'm again taking this on left hand side and bringing this 93 on the denominator on right hand side. So it's like 100 over 93. So again, now what I'll do, first I'll take square root of this. So your 1 plus R over 2 would be equal to square root of 100 over 93, and your R over 2 Let me just first calculate this. So 100 divided by 93 is coming around 1.0753. Okay, then let me just calculate square root of this. So 1 plus r over 2 is equal to 1.037. So r over 2 is equal to 1.073 minus 1. So r over 2 equal to 0.037. So your r would be equal to, let me just calculate. So it's 0.0739, which is in percentage term. Sorry, it's 7.39%. Again, it's 1 year spot rate with semi-annual compounding. So these are the two parts which were quite straightforward. For third, we may have to struggle a bit given there are intermediate coupons also. So let's have a look what's the situation there. So 1.5 year semi-annual compounding frequency is 6% per annum. That means 3% semi-annual is getting traded at 98.5 and maturity is 1.5 year. So I'm just summarizing the information that we have. So it's 98.5 and 6% per annum. That means your first 6 months you will get coupon of 3 months, and for 6 months spot rate is 6.19%. So what I'll do, I'll just use this. So it's called as a bootstrapping. First you calculated 6 months spot rate, then you calculate 1 year spot rate. Now I'll use this 6 months spot rate to discount this three. So it's 6.19% divided by 2. And as I said, the formula was T into N or N into T. So your compounding frequency is semi-annual, it's 2. And T, as I said, for 6 months, it's 0.5. And for 1 year, it's 1. And 1.5 year, it would be 1.5. I'm just writing this discounted cash flows. So it would be 3 over 1 plus 6.19%. Sorry, for 1 year, it's 7.39. Let's just correct it. The spot rate, it's not YTM, so it will be not constant. It may vary across tenors. So let me just write it for you. So it's 7.39% divided by 2 into N into T. N is our 2 and T in this case, it's first year. So it's 1. So important point to note here where 6 months is 0.5 or 1 year it's 1. And lastly, you will have 103, that is your par value plus the coupon of last maturity. And this R we have to calculate. This is spot rate for your this thing, your 1.5 year. So your N is constant and this T is 1 and 1.5. So it would be 3. So let me just quickly calculate for you. So I'll just have a look and quickly write it. You can calculate this on your calcs. So I will just use discounting factor. I think I already have. Without wasting much time, I'll just write what is the discounting factor for 6 months. Just a moment. So it's 0.97. So for 3, it's 0.97. And for this 3, it's 0.93. And for this 103, that in fact, we are interested in this R. So this 103, I'll just write this as 1 plus R over 2 to the power 3. 2 into 1.5 is 3. So what I'll do, I'll just calculate this and this, and I'll add these up, bring this on left-hand side, subtract it from 98.5. So let's quickly do it. So the total value for this is coming around, say, 5.7. This 3 into 0.97 plus 3 into 0.93, it's coming to be 5.7. You can check that out. And this is 103 divided by 1 plus r over 2 to the power 3. So I'll bring this minus. I'll just subtract 98, 5.7 from 98.5. So it's like 103 divided by 1 plus r by 2 to the power 3. And this would be around, say, 92.8 approximately. So 92.8 is equal to 103.1 plus. Now this is something similar to what we already tackled for zero coupon. So I can bring this over here, 103 over 92.8. So 1 plus r by 2 to the power 3, 103 divided by 92.8, and that's come around 03 to the power 92.8. It's around 1 plus r by 2 to the power 3 is equal to 1.1099. So what I'll do, I'll take cube root of this first. So 1 plus r over 2 into cube root of 1.1099. So 1 plus r by 2 would be equal to, just give me a moment, I'll calculate it on Calci. It's around 1.0354. So r by 2 would be equal to, I'll just subtract this 1 from there. So it would be 0.0354. And into 2 would be, just give me a moment, 0354 into 2. It's around 0.708. So r would be equal to around 0.708, which is equal to approximately 7.08%. So for 1.5 year, it's 7.08%. So we have for 6 months, for 1 year, this is for 1.5 years. Now we'll just calculate. I think the fourth part is we had to calculate it for 2 years and price is given to be 97.5. Let's do that part. So in the same way, it's 97.5. I would equate this with 3 over 1 plus 6.19% over 2 to the power. N is 2 and my T is 0.5 plus 3, 1 plus, it was 7.39, 7.39% over 2 divided by N is 2, my T in this case would be 1. For third portion, it would be 1 plus, I think it was 7.08%. So it's 7.08% over 2 to the power. N is constant, T in this case is 1.5 years. Plus last part is 103 coupon plus your power value. 1 plus R over 2 to the power. N is 2 and T is also 2. Second year, last principal, I mean T is also 2 in this case. So I would just calculate these terms for quickly for you. You can calculate, I'll not waste your time in video calculating these. So I have these quickly, I'll just write it along with 3. So it's again, I think it was previously also 3.97 plus 3 into 0.93. This is 1 over this discounting factor is 0.93 plus 3 into this discounting factor is 0.900971. And last component is something that we are interested in. So 103 plus 1 plus r over 2 divided by, so to the power 4. So I'll just calculate 97.5 is equal to, so these terms together, all these three terms together would be equal to 8.4029, and last component would be 103 plus 1 by 1 plus r by 2 to the power 4. I'll just subtract this 8.409 from 97.5 is equal to 1 over 3, 1 plus r over 2 divided by 4. And this subtraction will be equal to approximately 89.0971 equal to 103 divided by 1 plus r by 2 to the power 4. I'll just shift this on left hand side. I'll bring this on right hand side denominator. What I'll get 1 plus r over 4 to the power 4, 103, 89.0971, and the answer for this fraction is equal to, just give me a moment, calculate 103 divided by 89.097. It would be equal to, so let me just do it here for you. So 1 plus r over 2 to the power 4 equal to 1.156. I'll take fourth root of this. So to the power 0.25, it is equal to 1 point. So what I have done, just done this. It's equal to fourth power of 1.156. So your 1 plus r over 2 is equal to 1.0369. So your r over 2 equal to 0.0369. And if I multiply this by 2, it's 7.38. So this is spot rate for 2 years, semi-annual compounding. Not, but yeah, important to mention because this compounding frequency plays an important role. Hope you like the video. If yes, please do share with your peers. If you have got any feedback on the video, please do comment in the comment box. Stay connected with the channel. Thank you.